We start our discussion by understanding as to what does vertex mean. Let us take any great circle on the surface of the earth.
Beta, are you able to see the screen clearly and hear the audio going on?
Yes.
Yes, sir, loud and clear.
Yes, sir.
Okay, beta. Okay. So we are now going to understand the concept of vertex. What is this vertex? Now, once the concept is understood, then we will see how this is used to find intermediate positions. So let's proceed.
We see in the diagram the sphere of the earth showing up. We have the poles of the earth coming up on the diagram, followed by equator. And now we take any great circle except the equator. So equator has been left out of our discussion currently. So we take any other great circle. You can see a orange great circle showing up in the diagram. And we consider randomly points on it marked from A to H. So you can see these points also randomly showing up on the great circle drawn on the surface of the earth.
So beta, this is a 3D diagram. You can see the earth shown here, and the blue color circle which you see, that is basically the plane of the equator. So equator is shown in blue, the plane is filled up with the blue color, and the orange or yellow color circle which you see, that is any random great circle which we have picked up on the surface of earth. And on this random great circle, we have marked a few points. So you can see point A here. The point B is where the great circle track crosses the equator. Then you have point C here. The delta point is here. Then moving further, you have Eco, Foxtrot, Golf, Hotel. So up to here, have you understood this diagram, beta?
Yes, sir.
Okay, very good.
Now, if a vessel moves along this great circle, starting from A, along the direction of the arrows which are coming up on the screen, so she goes right round this great circle and returns back to point A. What
So what we are considering here is, let us assume that we have a ship at position A. Now that ship is moving along this great circle track. So when it is moving on the great circle track in the easterly direction, from A, the next point or waypoint which it will arrive is the Bravo, the B point. So at B point, it will be crossing the equator, and at the same time, it will also enter into the northern hemisphere. A to B stretch was in the southern hemisphere, but as it crosses B and proceeds ahead, it will be moving in the northern hemisphere. Then Bravo to Charlie, the next stretch will be in the northern hemisphere only. And as the vessel moves from Bravo to Charlie, you can see its latitude will keep on increasing. After Charlie Point, when it proceeds ahead towards Delta, the latitude again keeps on increasing. And you see at this point Delta, it will attain the highest latitude possible for this great circle. After delta point, the latitude will start to decrease. It will go on other side of the Earth sphere and it will start to move from delta to eco. So at eco, the latitude will be lesser than what was at delta point. And then from eco further, if it continues on the great circle track, it will move and come to position F, Foxtrot position, which is again at the equator. After Foxtrot, it is going to enter into the southern hemisphere. So F to G, Foxtrot to Golf, Golf to Hotel will be the stretch in southern hemisphere, and at H point, Hotel point, it will reach its maximum southerly latitude. After crossing H, again the latitude will start to decrease and it will again come back at A. So this is a complete great circle track around the Earth. So is this clear up to here, beta?
Yes.
Yes, sir.
Okay, very good. Let's proceed.
Do we see as the vessel sails along this great circle? We see that at each point, the vessel has a different course. Why? Because the great circle track cuts the meridian at each point at a different angle. Also, the coordinate of each point along the great circle, that is their latitude and longitude, are different. And what do we see as far as coordinates are concerned? That of all the points along the great circle, point D is the point where the vessel shall reach the highest northerly latitude. And likewise, point H would be the point where the vessel shall reach the highest southerly latitude. These 2 points, D and H, where the great circle has the highest latitude, or the points having the highest latitude along the great circle, are the points referred to as the vertices of the great circle.
So is it clear, beta, the vertex?
Yes, so the highest points along the track of the great circle.
Right. The highest latitude points on the great circle track. So you can now very well see that every great circle track will have 2 vertices. One will be in the northern hemisphere and the second one will be in the southern hemisphere. And also, beta, one very important thing which you should try to understand here is that when the vessel is moving on the great circle track, its course continuously keeps on changing. When we move on a rhumb-line track, our course does not change from the starting position to the destination. Moving along a rhumb-line track on a Mercator chart, the course does not change. The course remains the same. But when we move on a great circle track, the course continuously changes. Just to give you an idea, when the ship is at point B, you can see that the course of the ship will be somewhere in the northeasterly quadrant. It could be, we can assume that the course is 045 when the ship is at point B. Now, as it approaches ahead on the great circle track and reaches at point D, now at point D, the course will be 090. It will be exactly going into the screen. This is a 3D picture, 3D diagram being shown. So are you able to visualize better that at point D, the vessel will be going exactly into the screen and its course will be 090. Are you able to visualize that better?
Sir, please repeat.
Yes, it will be going.
Okay, okay. No problem. It will be repeated once again in the video also. Let me repeat it here also. Now at point B, let us say the vessel is proceeding on a course of 045. Okay. So you can see here the track is in the direction taking the ship in the northeasterly quadrant. So the course of the ship is 045. The northeasterly course takes the ship from B to C. Latitude is increasing. Now, when it goes from C to D, you see D is the highest latitude point. After crossing D, the latitude will start to decrease. Right, beta? This much is clear?
Yes, sir.
So at point D, the course of the ship would be exactly 090. After you cross D point, the course is going to fall into the southeasterly quadrant because अभी हमारा latitude D के बाद decrease होने वाला है. After crossing D, the course would be 091, 092, 095, 100, 120 that way. So are you able to visualize?
Yes, sir. Sir, one question, sir. Suppose
Bolo beta.
we are just going from A to B only.
Right, right.
Only A to B. Sir, then still our vertices will be D and H.
हाँ बेटा, wherever you are on this great circle track, whether you are going from A to B or from B to C or from C to E, F to H, anywhere,
Okay,
the
sir.
vertex of this great circle track will
Yes.
remain same. It will be delta to hotel.
ठीक है.
Because it is the arc of the great circle.
Let me go a little bit deeper. Let us say your initial position was A and the final position was B. Now you are moving from A to B, PAB
But
triangle.
highest latitude in that case will be only A, na, sir?
Ask again, beta.
Sir, I mean, in that case, our highest latitude will be A.
Right. As far as the ship is concerned, the highest latitude where the ship will go is point A,
Yes, sir.
because the ship is traveling between A to B only. But
Sir.
even in that case also, the vertex which we will consider will be the same vertex. In this case, we will be considering H as our vertex.
Sir, if the vessels sail in same hemisphere, then still have to calculate two vertex or only one?
Uh, for our calculation, we need only one vertex. So we are not going to find out both the vertex. We will only find one of the vertices. Which one we will find? We will find the vertex which is closer to our great circle track. Say for example, if the ship is going from A to B, the vertex which is closer to me is hotel H. So I will consider this vertex for my calculation. But if the vessel is going from C to E, Charlie to Echo, then the vertex which is closer is the delta vertex. So I will consider D as my vertex for my calculation purpose. For our calculation, we need only one vertex which is closer to our track.
And sir, supposedly, sir, ये जो B point है अभी equator पे है, and we shifted towards northern. मतलब अगर 8-10 degree we go to northerly course.
Right.
Then, so sir, we will be finding the H as a vertex or D as the vertex.
Okay. Now you check the latitude of both the places, beta. Initial and final places. दोनों का latitude आप check करो.
Okay.
जिसका भी latitude higher है,
Okay.
आप वही side का vertex ले लो.
अच्छा ठीक है सर, फिर ठीक. Okay.
Okay बेटा?
Okay सर.
Okay. अब एक और डाउट तुम्हारे माइंड में आना चाहिए.
Same latitude, sir.
If you are moving from let us say 20 south to 20 north, अब तो latitude same हो गया. आप कौन सा vertex ले? Say again बेटा.
कोई भी एक फाइंड कर लेते हैं सब सर.
Right. So अगर आपका latitude same है, let us say you are going from 20 south to 20 north. So in that case आपके दोनों हेमिस्फीयर में latitude same है. So आप कोई भी vertex अपनी choice का ले सकते हो, whichever you are comfortable with. Okay बेटा, it is clear up to here?
Yes sir, thank you.
Okay. अब एक और बात बेटा यहाँ पे समझने वाली है. ऐसा पॉसिबल है कि जब आप अपने ग्रेट सर्कल ट्रैक पे चल रहे हो तो वर्टेक्स आपके ट्रैक में ना आए. लेट अस से a ship is moving from Bravo to Charlie now. Bravo to Charlie. Bravo is the initial position. Charlie is the final position. अब जब शिप अपने ट्रैक पे चलेगा तो कोई भी वर्टेक्स हमारे ट्रैक के अंदर नहीं आ रहा है. We know the nearest vertex is D, but it is outside our track. Okay, this is one possibility. But अगर एक शिप जो है ब्रेवो से इको तक ट्रेवल कर रहा है, initial position is Bravo, final position is Eco. Now in this case, the vertex will lie on our track. So दोनों possibilities हैं. वर्टेक्स आपके ट्रैक के अंदर भी आ सकता है और वर्टेक्स ऐसा भी पॉसिबल है कि आपके ट्रैक में ना हो. It all depends upon your initial and final positions. Okay, beta, this is also understood?
Yes, sir.
Yes, sir.
Okay, so shall we proceed ahead?
Yes.
Okay.
Yes, sir.
So D and H are the vertices of the great circle. So based on the explanation of the vertex of a GC is a point at which the GC reaches the highest or maximum latitude. In other words, these are the points on the great circle which are closest to the poles. Now, based on this discussion, let's evaluate as to where are the vertices of the meridian. We know all meridians run north-south. Their highest latitude are the geographical poles. Therefore, vertices of every meridian happen to be the North Pole and the South Pole. Where are the vertices of the equator? Now, if you recall, when we started our discussion on vertex, we had left out equator. Why? Because equator is a very special great circle which runs in the east-west direction, and latitude of every point along the equator is 0 degrees. So therefore, the concept of vertex shall not apply to equator. Why? Because the latitudes are measured with respect to equator itself.
So this is also clear, beta?
Okay, sir.
Okay, all right.
Now, having understood what vertex means, let us understand some of the features of the vertex which will help us in solving certain questions. Now, every great circle, of course, excepting equator, has two vertices that are diametrically opposite to each other and one located in each of the hemispheres. With respect to this great circle in question here, we can see it has two vertices, vertex D and vertex H, diametrically opposite to each other, vertex D in the northern hemisphere and vertex H in the southern hemisphere. At the vertex, the great circle track is exactly east-west, and the other way of saying the same thing is that the great circle course of the ship at the vertices is east or west. That means it does not have any northerly or southerly component.
Now, beta, this is a very, very important property of the vertex, which we are going to use in our further questions, that when you reach at the vertex, moving along a great circle track, when you reach at the vertex, the direction of the great circle at that point is exactly east-west. It will not have any north or south component. In other words, it means that when you reach at the vertex, your course could either be 090 or 270. You cannot have any other course other than this. So this is also clear, beta?
Yes, sir.
Yes, sir.
Right. So this is a very, very important property. If you want, you can write it down in your notebooks. If you want to take a screenshot, you can take a screenshot also. We will be using it time and again. At the vertex, the great circle track is exactly east-west. That is, vessel's great circle course will be 090 or 270. Okay, beta, noted?
Yes.
Sir, 1 minute, sir.
Okay.
Okay, sir.
Okay.
Now to understand this, let's have a look at the highlighter moving along this great circle track, and we can see as it is moving along the great circle track, the northerly latitude is increasing. And we all know that this increase in northerly latitude is because of a northerly component in the course. And of course, this northerly component is continuously changing. What do we see as the vessel goes past point D, that is the vertex? The vessel's northerly latitude starts decreasing. Now, we also know that if the northerly latitude has started decreasing, the course must be now having a southerly component. Therefore, the vessel, as it was moving along here, the track here, had a northerly component of the course. Then it has the southerly component. So somewhere this change has taken place. And the place or the point where the change takes place is point D, where the northerly component was continuously decreasing, becoming zero at the vertex before the southerly component sets in. So at the vertex, there is no northerly component of the course, there is no southerly component of the course. Therefore, the vessel's course will be either east or west. As the vessel is always aligned along the great circle, therefore, it also means that the great circle track at the vertex or the vertices is running in the east-west direction.
So this is clear, beta?
Yes, sir.
Yes, sir.
Okay, all right.
The vertices will be located with a D long of 090 degrees from the positions where the great circle cuts the equator. Now, this great circle is cutting the equator at point P and point F. Vertices are D and H. That means D long between B and D is 90, D and F is 90, F and H is 90, H and B is 90. It's very simple to understand that. If a vessel starts from B, goes along this great circle track and comes back to point B, the D long is 360 degrees. Now, these points, that is point B, D, F, H, B, they divide the great circle into 4 quadrants.
So this is also clear, beta?
The latitude of the vertices will be equal to the inclination between the plane of equator and the plane of the great circle, or the angle at which a great circle cuts the equator represents the latitude of the vertex. So first, let us identify the angle between the planes of the equator and the great circle. This is the angle in our case, which is the angle of inclination between the plane of this great circle and the plane of equator. Now, if we join this point D with the center of the earth with a straight line, I'm sure we can all visualize that this particular line shall be in the plane of the great circle. So if this line is going to be in the plane of this great circle, then this line shall make the same angle as this one with the plane of equator. And we all know that the angle subtended by a point on the surface of the earth with the plane of equator at the center of the earth represents its latitude. Therefore, this angle of inclination becomes the latitude of the vertex.
So were you able to understand this point, beta? Okay. What it says, beta, this property of the vertex, it says the angle of inclination or the angle of cut between the plane of the equator. The blue color plane which you see in the diagram is the plane of the equator. So the angle between this and the plane of the great circle, this angle is represented or highlighted by the orange color in the diagram. Now this angle will be equal to the latitude of the vertex. Is it clear now, beta?
Yes, sir. This is
Okay, so it
clear.
is a great
Oh.
circular plane cutting the plane of equator.
Yes, that's right. The angle between both of them will be equal to the latitude of the vertex. Now, beta, tell me one thing. Let me give you a small question to test your understanding of this concept. Let us say our ship is moving on a great circle track and we are at point B. Okay, we are crossing the equator and proceeding towards C. So our ship is right now at point B and it is proceeding towards C point, Charlie point. Now, let us say we know that this great circle track on which we are moving, its vertex is at 40-degree latitude. So the latitude of the vertex or latitude of point D is 40 degrees. Now, can you tell me, beta, what will be the course of the ship at Bravo point?
050.
Everybody agrees? 050, beta? Any other answer? Okay, good beta.
Still,
That's
latitude कितना बोला सर आपने?
040
40 degree beta latitude. Latitude is 40 degrees of the vertex of point D. So second option which is coming up is 040. Any other option beta?
Sir 050 होगा sir.
Very good. So it will be 050 beta. You see, if the latitude of point D is 40 degrees, that means this highlighted angle, the orange highlighted angle, will also be 40 degrees. That means with respect to the equator, our great circle track is at a 40-degree angle. Now equator direction represents east-west direction. So 090 direction. If you are 40-degree north of it, your course has to be 050. Our course is measured with reference to north and south, whereas the equator is in the east-west direction. So our course here would be 050. That's the correct answer, beta. So is it clear to everyone, beta?
Yes, sir.
Yes, sir.
Okay, all right. Let's proceed ahead now.
The great circle track intersects the meridian of the vertex at 90 degrees angle. This issue has already been addressed when we inferred that the course of the vessel at the vertices would be east or west, or the great circle track shall be east or west at the vertices. And we know these directions are measured from true north, and north-south is represented by the meridian. Therefore, the angle between the meridian and the great circle at the vertices shall be 90 degrees.
Now this is also very important, beta. The great circle track will intersect the meridian of the vertex at 90-degree angle. Basically what we are saying here is that this great circle track which you see, let us consider this point delta. We know at point delta, the great circle track is running in the east-west direction, 090 and 270 direction. So our great circle track is in east-west direction. And what is the direction in which the meridians run, beta?
North-south direction.
So we know all the meridians, they run in the north-south direction. In this diagram, this particular meridian which you see, NP2 delta, it is basically the meridian of the vertex. So meridian runs north-south. Our great circle track at the vertex runs east-west. So there has to be a 90-degree angle between them. So this tells us that the great circle track intersects or cuts the meridian of the vertex at 90-degree angle. So at the vertex, this angle would be 90 degrees, not at any other point, because at other points, the direction of the great circle track is going to change. It will not remain east-west. It is only at this particular point, that is the vertex, which is the delta point, that the great circle track will be at right angles to the meridian. So this is clear to everyone, beta?
Yes, sir.
Okay, all right. Let's proceed ahead.
A vessel's track may or may not pass through the vertex of the great circle. Of course, the entire great circle has only two vertices. We may be traveling only over a part of the great circle track. So it may include the vertex or it may not include the vertex. For example, if I travel along this great circle from B to C, then over this arc, I do not include any of the vertices. But if the great circle, if I have to travel from C to E, then I shall be passing through vertex D. So my track may include a vertex or may not include a vertex.
So beta, is this point also clear? That when you are moving on a certain portion of the great circle track, it is possible
Yes,
that the
sir.
vertex may lie in between your initial and final positions, or there is a possibility it may lie outside your initial and final positions. So is that clear, beta?
Yes, sir.
All
Yes,
right.
sir.
Now this is also very important when we calculate the position of the vertex. This is the first thing which we need to check. When we are given a question, find out the position of the vertex. The first thing which we need to check is whether the vertex lies between our initial and final positions or the vertex lies outside the initial and final position. ये पहली चीज है जो हमें चेक करनी होती है. इसका मेथड मैं आपको बताऊंगा कैसे इस चीज को चेक करते हैं. वी कैन इजीली फाइंड इट आउट. वी डू नॉट नीड टू मेक दिस फुल अर्थ डायग्राम. We can easily find it out using another method. So I will explain you what that method is. If you go from B to C, initial position is Bravo, final position is Charlie. Vertex will be outside your track. But if you go from C to E, Charlie to Echo, in that case, vertex will be inside or lying on your track. So this is what we will be checking as the first thing when we find the position of the vertex.
In our calculation, we shall be dealing with the vertex that is closer to our great circle track. So if it lies within the track, obviously that's the closest one. If it does not lie within the track, then our interest would be in the vertex that is closer to our track.
So this next point, it says because there are two vertices of every great circle track, which vertex should we find out? Let us say the question says find the position of the vertex for this particular great circle track. This is the initial position, this is the final position. So we know for every great circle there are two vertices. Which one should we find out? So in that case, we always find out or consider the vertex which is closer to our track. So if it lies between our track, let us say if you are going from C to E, then there is no confusion at all. The delta vertex will be the closer vertex. But if you are going from Bravo to Charlie, B to C, so then the delta vertex or the hotel vertex both are outside our track. So out of these two, which one we will be using? We will be using the one which is closer to us. So we will be using the delta vertex in this case. So this is also clear, beta. Any doubt up to here?
No, sir.
No, sir.
Very good.
To figure out whether vertex.
Okay, so now we move on to the calculation of the vertex principle. We have seen the properties of the vertex. Now, as I told you, beta, the first most important thing which we need to know is whether the vertex lies in between our initial and final position or it lies outside our initial and final positions. So how do we check that out? अब बेटा आगे जो टॉपिक्स हमारे आ रहे हैं, we have done basic great circle sailing question. Now we are moving on to vertex and intermediate position. Later on we will be moving on to composite sailing. All these topics, they are interconnected with each other. It basically means कि जो great circle का concept है, जो PAB triangle हमने बनाई है, angle A, angle B calculate किया है, GC distance calculate किया है. Now this knowledge will be required, this concept will be required till the time we go to the last concept of composite sailing. It is something like building a house. With the great circle simple questions, we have made the foundation of the house. Now with the vertex and intermediate position, we are making the ground floor. And then with the composite sailing, we will be making the first floor. So foundation has to be there, then only the ground floor and first floor can be made. So we will be using the same concept which we learned in great circle sailing to find the vertex, the intermediate position, and later on in the composite sailing also. We are trying to find the position of the vertex, and the first thing which we need to know is whether vertex is inside our initial and final positions or outside. So for this, we will have to first make the PAB triangle as we made in GC sailing, exactly like that. And we will have to calculate the great circle distance as well as angle A and angle B. इतना काम बेटा हमने ग्रेट सर्कल सेलिंग के क्वेश्चन में किया था. अगर हमें वर्टेक्स को ढूंढना है तो ये काम पहले करना पड़ेगा. Whether the great circle distance is asked in the question or not does not matter. If you want to find the position of the vertex, you will have to make the PAB triangle, find the GC distance, and then find angle A and angle B. So up to here, everybody is clear?
यस सर. सर जो
Yes,
लिमिटिंग
sir.
लैटिट्यूड के क्वेश्चन आते हैं वही भी सेम होते हैं सर, ये वर्टेक्स वाले ही हैं.
Ask again, beta.
सर मैं कह रहा था कि जो लिमिटिंग लैटिट्यूड के क्वेश्चन आते हैं
Right.
वो भी सर वर्टेक्स वाले ही क्वेश्चन है सारे.
नहीं बेटा, जो लिमिटिंग लैटिट्यूड का कॉन्सेप्ट है वो कंपोजिट सेलिंग में आएगा. अभी हम इसके बाद करेंगे व्हेन वी फिनिश ऑफ द ग्रेट सर्कल सेलिंग, वर्टेक्स एंड इंटरमीडिएट पोजीशन जब हम कंप्लीट कर लेंगे, then we move on to composite sailing where I will explain you this concept of limiting latitude.
ओके सर.
Okay, उसमें भी vertex use होगा, but I will explain it to you in detail when we reach up to there. So for now we do not have any limiting latitude anywhere. Okay, और कोई डाउट बेटा अभी तक? Okay, now everybody is
No, sir.
familiar with calculating great circle distance, angle A and angle B. इसमें किसी को कोई डाउट तो नहीं है बेटा? क्वेश्चन सॉल्व हो रहे हैं? Okay, I take silence as tacit acceptance. So let's proceed ahead now and see that after solving the PAB triangle, when we find the GC distance, we find angle A, we find angle B. How to determine whether vertex is inside or vertex is outside our initial final position or the PAB triangle. So we are going to see that now.
To figure out whether the vertex of the great circle lies within the GC track of the vessel or it lies outside the GC track, we use angles A and B of the PAB triangle. We calculate the angles A and B, and if angle A and B are both acute, that is both are less than 90 degrees, then the vertex lies inside the track, that means between A and B somewhere. Let's look at it through a diagram. We have the pole, we have position A, position B. We draw the meridians of both the positions. We join them with the arc of a great circle, so we have a PAB triangle. We solve it. We have already learned in volume 1 of this series on great circle how to solve for angle A and B. And if angle A and B are found to be both acute, the vertex shall lie somewhere between A and B. So we can take any point along this where we feel appropriate, represent that by V as the vertex. We draw the meridian of this vertex from P, and we have already seen in the features of the great circle that.
Okay, so beta, up to here is clear to everyone. Any doubt, ask me, beta.
Clear, sir.
Okay, so important thing जो हमें check करनी है, when we solve the PAB triangle, first of all we will be finding the great circle distance. As usual, जैसा हमने पहले किया था, बिल्कुल वैसे ही हम great circle distance find out करेंगे. After great circle distance, the next thing which we are going to find out is angle A and angle B. ये दोनों angles को हमने find out करना है. Now, once you find these two angles, look at them carefully. Whether these angles are acute, acute means less than 90 degrees, or is any one of them obtuse? Obtuse means greater than 90 degrees. So let us say condition number 1, आपने ये दोनों एंगल चेक किए. Angle A was 30 degrees, angle B was 60 degrees. आपने देखा कि दोनों के दोनों एंगल एक्यूट हैं, मीन्स 90 डिग्री से कम है. अगर दोनों एंगल एक्यूट एंगल्स हैं, लेस देन 90 degrees, the vertex has to lie between A and B. So the vertex will lie inside our PAB triangle. That is the first thing. So is it clear now, beta, in your mind? No doubt?
Yes, sir.
Very good. Now, beta, what is the direction of the great circle track on the vertex?
East or west?
Very good. We know the direction of great circle track at the vertex is east-west. And can you tell me in this diagram, beta, what is this PV, Papa Victor line?
Meridian.
Very good. It is the meridian of the vertex. You see, what was PA, beta?
Colat of
It is
A.
a collat.
Yeah, its
Colat of A.
magnitude was colat of A, and this was a part of the meridian of A. Similarly, the PB
The
magnitude
arc of
was
the
equal.
meridian.
Yes, it is the arc of meridian of point Bravo. So similarly, Papa Victor is the arc of the meridian of the vertex. So we now have Papa Victor as the meridian of the vertex. The great circle track is moving in the east-west direction. So can you tell me what will be this angle V in both the triangles? What will be this angle,
सर
Victor?
90 होगा ना सर ये वाला तो फिर.
Very good, beta. Very good, very good. So if you have understood this, then our path becomes clear. This angle here at Victor will be 90 degrees.
सर ये जो EB होगा एक तरीके से कोलेट ऑफ अपना वो हो जाएगा ना वर्टेक्स.
Very good, beta. Very good. You are exactly thinking in the right direction. Papa
Okay, sir.
Victor magnitude will be the colat of the vertex. Exactly as PA was the colat of A, Papa Bravo was the colat of B. Similarly, Papa Victor will be the colat of the vertex. So if you can somehow calculate this PV side, you will be able to find the latitude of the vertex. Very good, beta.
Sir,
सर ये 90
this
डिग्री कैसे
angle
होगा
V
एंगल?
is
Okay.
sir angle V is getting 90 degree because of the it is running east west because of its course, right, sir?
राइट बेटा. एंगल V 90 डिग्री कैसे हुआ? देखो बेटा, जो पापा वेक्टर है ये है मेरिडियन. हमें पता है ऑल द मेरिडियंस रन नॉर्थ साउथ. और जो ग्रेट सर्कल है, ग्रेट सर्कल ट्रैक वर्टेक्स पे ईस्ट वेस्ट डायरेक्शन में रन करता है. सो डायरेक्शन ऑफ द जीसी ट्रैक इज ईस्ट वेस्ट. डायरेक्शन ऑफ पापा वेक्टर इज नॉर्थ साउथ. तो इन दोनों के बीच में क्या एंगल बनेगा बेटा? Is it clear now, beta?
यस सर.
Okay. So shall we move ahead now?
Yes, sir.
यस सर.
This meridian shall cut the great circle at 90 degrees at the vertex. So this angle is 90. However, on solving for angles A and B of the PAB triangle, if we find that any one angle happens to be acute and the other one obtuse.
Okay. अब बेटा हम आ रहे हैं सेकेंड कंडीशन पे. हमने एंगल A और एंगल B को फाइंड आउट किया बाय यूजिंग द कोसाइन फॉर्मूला. वन एंगल इज एक्यूट. एक एंगल जो है ये एक्यूट आ गया, मींस लेस देन 90 डिग्रीज. और जो दूसरा एंगल है वो ऑब्ट्यूस मिला है हमें. लेट अस से 110 degrees. So one angle is acute, other angle is obtuse. अब ऐसे केस में वर्टेक्स कहाँ जाएगा? The vertex now lies outside the GC track. That is outside the PAB triangle. So अगर दोनों में से कोई भी एंगल ऑब्ट्यूस हो जाए, ग्रेटर देन 90 डिग्री हो जाए, तो इसका यही मतलब है कि वर्टेक्स ट्रायंगल के बाहर बनेगा, अंदर नहीं बनेगा. दैट मीन्स आवर ग्रेट सर्कल ट्रैक विल नॉट हैव द वर्टेक्स इनसाइड. सो दैट इज द फर्स्ट थिंग. दिस इज क्लियर इन द माइंड बेटा? एनी डाउट्स?
नो सर.
अब बेटा दूसरी चीज आती है. हमें ये तो पता चल गया कि वर्टेक्स जो है ट्रायंगल के बाहर बनेगा. अब जो सेकेंड डाउट माइंड में आएगा वो ये कि ट्रायंगल के बाहर हम इसे किस तरफ बनाएं. ट्रायंगल के बाहर तो हम ए की साइड में भी जा सकते हैं, ट्रायंगल के बाहर हम बी की साइड में भी जा सकते हैं. तो वर्टेक्स को किस तरफ बाहर लेके जाना है? सो उसके लिए ऑलवेज रिमेंबर, वर्टेक्स विल बी ऑलवेज ऑन द साइड ऑफ द ऑब्ट्यूस एंगल. जिस तरफ ऑब्ट्यूस एंगल बनेगा, ग्रेटर देन 90 एंगल बनेगा, हमारा वर्टेक्स भी उसी डायरेक्शन में ट्रायंगल के बाहर बनेगा. So I will show you this thing now with the diagram. We will make the diagram here. Let's see.
Then the vertex shall lie outside the track and it shall lie on the side of the obtuse angle. Let's look at this through a diagram. Here is the pole, here is angle position A, Position B, their meridians joined by a great circle track. PAB triangle solved for angle A and B. Angle A found to be acute, but angle B found to be obtuse.
So you can see in the diagram now, beta, one angle is acute and the other angle is obtuse. So will the vertex be inside or outside?
Outside.
B के
Outside, sir. Outside.
Very good. And on which
B
side
की
will
तरफ
be
बनेगा
out?
outside.
On the
B की
On
तरफ
obtuse
the
angle
B.
side.
On the
Very
side
good,
of B.
beta. Very good. You have understood. Great.
Now, in this case, the vertex shall not lie on the track between AB. It shall be outside the track, and the closer one shall be on this side of the great circle. That means towards the obtuse angle. So we mark a point somewhere here as vertex. So here is vertex. We draw its meridian through the pole. Needless to say, it will make an angle of 90 degrees with the great circle.
ओके अब बेटा चाहे वर्टेक्स अंदर बने या वर्टेक्स बाहर बने, जो एंगल V बनना है, angle V, that will always be 90 degrees, because whether the vertex is inside or outside, great circle track will always run in east-west direction at that point, and Papa Victor line which we are seeing, this Papa Victor line is the meridian of the vertex which will run north-south. So irrespective of whether it is inside or outside the triangle, the angle here at the vertex will always be 90 degrees. So is it clear up to here, beta? Any doubts in the mind?
सर एक डाउट है कि जैसे जब इनसाइड होगा तो पता लग जाएगा कौन सा हेमिस्फीयर में है एज पर द लैटिट्यूड ऑफ ए एंड बी, और अगर आउटसाइड होगा तो भी सर बी के पास लैटिट्यूड में है.
बिल्कुल बेटा, जो भी आपका ऑब्ट्यूस एंगल बन रहा है उस पोजीशन को देखो, उस पोजीशन का जो भी लैटिट्यूड है आपका वर्टेक्स का भी वही हेमिस्फीयर है.
ओके
ओके ओके, और बताओ बेटा, और कोई डाउट आ रहा है?
Sir, कितना it will be outside. Suppose if the point B latitude is about closer to the equator, then
You mean to say the point B is close to the equator?
suppose
Okay.
Point A latitude is at 30 degrees south and point B latitude is 2 degrees south, about 5 degrees south. So if it is going outside on the obtuse angle, so it can be possible, it can be even go northern hemisphere.
नहीं बेटा, ऐसा कभी नहीं होगा. जो ऑब्ट्यूस एंगल बनेगा, इट विल ऑलवेज बी द हायर लैटिट्यूड. ये कभी भी लोअर लैटिट्यूड में नहीं बनेगा. ये आपको ध्यान रखने की जरूरत नहीं है, ऑटोमेटिकली ऐसा ही होगा.
Okay, sir.
ओके
Sir, sir, this is
बोलो.
Ankush. I completely missed out, sir. There was a internet connection lost. Completely missed out everything.
नो
On that question I
प्रॉब्लम
asked.
बेटा, डोंट वरी एट ऑल. ये वीडियो यूट्यूब पे अवेलेबल है, और
Yes.
अभी आप क्लास के बाद इसको डाउनलोड कर लेना. यू शुड बी एबल टू डाउनलोड इट, सो नॉट एन इशू. यू कैन हियर टू द लेक्चर अगेन, एंड जितना भी आपने मिस किया है उसमें अगर कोई भी डाउट आता है, आस्क मी इन द नेक्स्ट क्लास.
जी. Okay, sir.
ओके. और बताओ बेटा, और कोई डाउट है अभी तक?
So, sir, naming of the vertex which is lying outside of the triangle will be always same as obtuse angle latitude, right, sir?
दैट्स राइट बेटा. जो भी आपका ऑब्ट्यूस एंगल वाली पोजीशन का लैटिट्यूड है, आपके वर्टेक्स का लैटिट्यूड भी उसके सेम नेम का ही होगा. So shall we move
Okay, sir.
ahead? Shall we move ahead now, beta?
Yes, sir.
Okay.
Now, having identified whether the vertex lies inside the track or outside the track, what do we use it for? What is our interest in the vertex that we have discussed it for so long? Now, the importance of vertex lies is in the fact that the vertex, the meridian of the vertex, cuts the great circle at 90 degrees. So This angle at the vertex between the GC track and the meridian of the vertex is 90 degrees is a very, very important feature. Why? Because this gives us special spherical triangle, which is called as right-angled spherical triangle. And such triangles can be much more conveniently solved using Napier's rule.
Okay, so